Today I am discussing about the sag. While creating an overhead line, it is very vital that the conductors are under safe tension. If the conductors are too much stressed between support in a bed of safe conductor materials, the stress in the conductor may be reach unsafe value, and certain case the conductor may be break due to the excessive tension. In order to permit safe tension in the conductors, they are not fulfilled stretched but are allowed to have a dip or sag. Now, what is sag? The difference in level between the point of support and the tower point on the conductor is called the sag. The figure 1 shows the conductor suspended between two equivalent and equilevel support A and B. The conductor is not fully stressed but is allowed to have a dip. The lowest point on the conductor is O and the sag S. So here this is the transmission conductor where A and B are the 2 points which is connected with the tower, and the nature of conduct is just like this, like a sag is present here. So sag is defined at the conductor terminal point to the end point of the distance, like here is the sag. Now some following factors are related with the sag, like when the conductor is suspended between two support at the same level, it takes the shape of like the figure. However, if the sag is very small compared to with the span, the sag span curve is just like a parabola. Next point, the tension at any point on the conductor acts tangentially. Thus, the tension T0 at the lowest point O at horizontal as shown in the figure 2. Next point, the horizontal component of tension is constant throughout the length of the wire. Next point, the tension at supports is approximately equal to the horizontal tension acting at the point on the wire. Thus, if T is the tension at the support B, then T equals to T0. So, in this figure, this is the T and this is the T0 is the tension. Now, the calculation of sag. In an overhead line, the sag should be so adjusted that the tension in the conductor is within a safe limit. So, sag is basically always present within a safe limit. The tension is governed by the conductor weight, effect of wind, ice loading, and the temperature variations. It is standard practice to keep the conductor tension less than 50% of its ultimate tensile strength. That is, minimum factor of the safety is respect to the conductor tension should be 2, that is 50%. We shall now calculate the sag and the tension of the conductor. First method is the supported are at equal level. When the supports are in equal level, then here point A and point B are two line support, because conductor are attached with the two terminals, and here or the tower is present and here at a tower is also present. Now consider the conductor between two equilevel point A and B with the O is the lowest level. This is O is the lowest level of the path. Now, according to the figure, we consider L is the length of the span, W equals to the weight per unit length of the conductors, T is the tension of the conductors. Now, consider a point P on the conductor. Suppose this is point P on the conductor, taking the lowest point O at the origin. We consider this is the lowest point O and this is the origin of the diagram. Let coordinates of point P are x and y. So this is x axis, that means horizontal axis, and the vertical axis is denoted by y. So this is y and this is the x. Considering that the curvature is so small that curved length is equal to its horizontal projection, that means OP equals to x. Here we consider the point OP. This is O and this is P, and the length of the OP, the straight length of the OP is this, and we can consider the distance is x. The two forces acting on the portion OP of the conductors are: number one, the weight Wx of the conductor acting at the horizon, acting at a distance x by 2 from O. So this is Wx. This is a force which is acting in the at the mid position of the x, and this point is considered x by 2. This is x by 2, and this is also x by 2. And tension T acting on O. This is the tension which act on the point of O. So there will be two forces in this case. Now equating the moment of the above two forces about point O, then we can get Ty equals to Wx into x by 2. That means y equals to Wx square divided by 2t. The maximum sag is represented by the value of the y at either the support A and B. At support A, x equals to L by 2 and y equals to S. So therefore the sag S equals to W into L by 2 whole square divided by 2t, and that is equals to WL square by 8t, and that is the basic formula of the sag. Now effect of wind and ice loading on the sag. So sag is the basically the distance between the conductors, starting point of the conductor and to the lowest point, that is called the sag. Sag is depends upon different types of forces. Sag, basically the sag is present in the outdoor lines, outdoor substation or outdoor lines so there are some wind effect and ice effect are also present regarding the sag. Now the formation of the sag are only due to the air and normal temperature when the conductor is acting by the weight only. However, in actual practice, the sag is not totally occurred due to the weight of the conductor, but some external factors are present there. Now in actually, a conductor may have ice coating or simultaneously subjected to the wind pressure. The wind pressure and the weight of ice acts, the weight of ice acts vertically downward in the same direction as the weight of the conductor. So weight always act vertically according to the gravitational force, and the weight of ice act vertically downwards at the same direction as the weight of the conductors. The force due to the wind is considered to act horizontally, and wind always flow in this direction, like horizontal direction. So that is at right angle of the projected surface of the conductor. Hence the total force on the conductor is the vector sum of the horizontal and vertical force as shown in the figure. So there are two forces, that is WW, that is the wind pressure, and this is the pressure of the weight and the ice. So here the weight of the conductor per unit length, Wt equals to root over of W plus Wi whole square plus WW square, where W equals to the weight of the conductor per unit length, that is equals to the conductor material density into volume per unit length. Wi is the weight of the ice per unit length, that is equals to the density of ice into volume of the ice per unit length, that is also equals to the density of ice into pi by 4 into d plus 2t whole square minus d square into 1. So that is equals to the density of ice into pi by t into d plus t. WW is the wind force per unit length which is act horizontally. You already know that. That is equals to wind pressure per unit area into projection area per unit length, and that is also equals to the wind pressure into d plus 2t into 1. When the conductor has wind and ice loaded also, that means two effects are there, then first case the conductor itself is a plant and lie on a single plane at an angle theta and to the vertical, where tan theta equals to WW divided by W plus WI. Next point, the sag in the conductor is given by S equals to WT into L square divided by 2T. Hence, S represent the slant sag in the direction making an angle theta to the vertical. If no specific mention is made the problem, the slant sag is calculated by using the above formula, and the vertical sag is also denoted by S cos theta. Now a problem related with the sag. A transmission line has a span of 150 meter between the level support. The conductor has a cross-sectional area of 2 cm square. The tension in the conductor is 2000 kg if the specific gravity of the conductor material is 9.9 gram per centimeter cube and the wind pressure is 1.5 kg per meter length. Calculate the sag. Now, and what is the vertical sag? And this is the solution. According to the problem, the span length is 150 meter, the working tension T equals to 2000 kg, the wind force per meter length of the conductor is WW, that is equals to 1.5 kg. Now, the weight of the conductor per meter square length W equals to the specific gravity into volume of 1 meter conductor, and that is equals to 9.9 into 2 into 100, and that is equals to 19 into 980 gram, and that is equals to 1.98 kg. Therefore, the total weight of 1 meter length of the conductor is WT equals to root over of W square plus WW square. Here the value of W is 1.98 and value of WW is 1.5. So that is equals to root over of 1.98 square plus 1.5 square. And the answer is 2.48 kg. Therefore, finally, the sag S equals to WT L square by 8T. So WT is the value of WT 2.48 and the value of L is 150 and the value of T is 2000. So therefore 2.84 into 150 square divided by 8 into 2000, that is equals to 3.48 meter. Now this is the vector diagram where the horizontal axis indicates the WW, that is wind force, and the vertical axis is denoted by W and resultant is WT. This is the value of the slant sag in the direction of the making an angle theta with the vertical. In the vector diagram, the value of theta is given by tan theta equals to WW by W, that is equals to 1.5 divided by 1.98, and that is equals to 0.76. Therefore, theta equals to tan inverse 0.76, that is 37.28 degree. This is the value of theta. Therefore, the vertical sag, the formula is S cos theta. So, S, that means sag equals to 3.48 into cos 37.23, which is already calculated from the previous stage. So, the answer is 2.77 meter.